Warm welcome to Module 9 of our series on polygons. In this module, we will focus on special quadrilaterals, parallelograms, and explore their key properties. As discussed in the previous modules, to gain an understanding of any polygon, we must examine its three fundamental elements: the sides, the angles, and the diagonals. In this session, we begin by taking a closer look at the sides of a parallelogram. Observe this quadrilateral on the screen. What do you notice about its opposite sides? The opposite sides are equidistant from each other. They always maintain the same distance apart. And this is indicated by the red arrows. So what is your observation about the other pair of opposite sides? Are they also parallel? Absolutely. And this is also indicated by the green arrows. This is the defining characteristic of a parallelogram. When both pairs of opposite sides are parallel, such special quadrilaterals are called parallelograms. So we can conclude, to classify a quadrilateral as a parallelogram, the first essential condition is that both pairs of opposite sides must be parallel. This is the foundational property, but this is not the only one for the sides of a parallelogram. Observe the quadrilateral on screen. We have taken one side of this quadrilateral, copied it exactly, and aligned it with its opposite side. What do you observe? They don't merely run parallel to one another, they also match perfectly in length. We can see they are overlapping and superimposing each other, showing that they are equal in measurement and also are parallel. That is why parallelograms have a strong structural balance. So, what can we conclude about the opposite sides of a parallelogram? The opposite sides of a parallelogram are not just parallel, but they are also equal. It is this combination of parallelism and equality that helps us recognize and classify parallelograms with confidence. Identify the parallel and the opposite sides and complete the statement. So, a parallelogram is a quadrilateral with two pairs of opposite sides that are parallel and equal. Let's begin with side AB. Observe the blue arrows. So, AB is parallel to CD, and also AB is equal to CD. The other pair of parallel and opposite sides will be BC, which is parallel to AD, and also BC is equal to AD. This formally brings us to the definition of parallelogram. Let us apply this knowledge to find some missing values. For example, in this parallelogram, we have been asked to find out the missing values x and y. In such cases, the first thing is to identify the given element. So, have we been provided with information on sides, or are these angles, or are they the diagonals? Clearly, they are the sides. So, the essential concept that comes to our mind is that the opposite sides of a parallelogram are equal. So now we will quickly equate 3x to 18. Pause the video and solve to find the value of x and y. So 3 times x is 18, which implies x is equal to 6. Similarly, we equate 3 times y, but we are subtracting 1 from it to get 26. That means the first thing is we will add 1 back to 26, and we have 3 times y, 27, which means y will be equal to 9. If you have any doubt with linear equations and their setup or solution, refer to our playlist on linear equations. As of now, we found the values of x and y. One more question for your practice. Pause the video to match your learning pace. So, we know that sides are given to us. We will write the property. Writing property is an essential part of your presentation. Equate the variable set, the expression, to 40. Since they have added 2 to 2 times x, we will first subtract 2 to get 38 and divide it by 2, bringing us to the value of x, which is 19. That was all that there was to the properties of sides of a parallelogram. So we conclude that the opposite sides of parallelogram are parallel and equal. Moving on to the second essential concept, that is angles. Imagine four friends are sitting around a table A, B, C and D. Take a moment to observe who is sitting directly opposite to A. A and C are sitting opposite to each other, which implies that there are two people adjacent to A, and these are B and D. Something similar to what we had done in our series on vertically opposite angles and adjacent angles or linear pair angle. This arrangement will help us relate to the idea of opposite and adjacent angles in a parallelogram. Take a look at the parallelogram displayed on your screen. Focus your attention on angle A. Just like in our earlier example, the angle directly opposite A or directly across A is angle C. So we can say angle A and angle C are opposite. Meanwhile, the angles positioned next to angle A are angle B and angle D. So we can say angle B and angle D are adjacent to angle A. An important observation: one angle will be opposite and two angles will be adjacent in a setup of a quadrilateral. Now that we have clearly identified the opposite and adjacent angles, let's observe how they behave in a parallelogram. Take a look at the demonstration on screen. We have highlighted two angles, one in pink and one in blue. Let's make a copy of the pink angle and move it across to the opposite corner. What do you observe? It fits completely into the vertex, and if we do the same with the blue angle, this also fits exactly, no gaps and no mismatch. So what conclusion can we draw? That the opposite angles of a parallelogram are perfect. The opposite angles of a parallelogram are equal. These demonstrations on screen help you to organize information and recall it later. So, no matter what the size or the tilt of the parallelogram is, this property will always hold true. Observe angle C and angle A. How, if angle C is turning into 104, angle A is also turning into 104. Same is happening with angle B. It is 70, so the opposite angle D is also 70. What conclusion can you draw to fill in the blank? The opposite angles of a parallelogram are equal. Let us now investigate the behavior of adjacent angle. A line is drawn parallel to one side of parallelogram by making sure that the corresponding angles are equal. The corresponding angles are marked pink in this demonstration. So you can see that adjacent angle, blue adjacent angle has been placed along with pink angle. And what are they forming? They are forming a linear pair. So what relationship is revealed? That the adjacent angles are the pink and the blue angle. The adjacent angles of a parallelogram are, what conclusion can you draw? Observe the demonstration closely. See how the two lines are overlapping but they will never cross each other. So pink angles are the corresponding angles and they are the opposite angles. The blue angle is adjacent to the pink angle and pink and blue are forming a linear pair. So we can conclude the adjacent angles of a parallelogram are supplementary. They will add up to 180 degrees. So let's draw our conclusion using this observation. If you observe, the two adjacent angles to angle A are D and B. If you add A to B at any point in time, the answer will always be 180 degrees. The adjacent angles of a parallelogram are supplementary. They are supplementary. So we have two properties now. That the angles opposite are equal but adjacent are supplementary. Let's put it to practice. Find all missing angles in the given parallelogram. In the given parallelogram ring, angle R is given to us as 70 degree. We are required to find the opposite angle N, and the two adjacent angles I and G. Pause the video and find the missing angles. So the first property is for opposite angles. Opposite angles of a parallelogram are equal. So we know that opposite angle N is also 70. As discussed previously, one angle is opposite and two angles are adjacent. And to find the missing adjacent angle I and G, we will simply subtract the given angle from 180 degrees because the adjacent angles are supplementary. So angle I will be 180 degrees minus 70 degree, and same will go for angle G also. Angle G and angle I will be equal to 110 while angle N will be 70 degree. Now one more question for your practice. Find all missing angles of the given parallelogram. Pause the video to match your learning pace. So one angle has been provided to us and the opposite angle D is missing and two adjacent angles are missing. In a second, you know that angle D will also be 100 degrees because it's opposite, and the remaining two angles will be 180 degree minus 100 degrees. That is, both of them will be equal to 80 degrees. Perfect. So we have found the three missing angles X, Y and Z. Having already understood the sides and angles, we are now ready to look deeper into the third essential element. But before that, the sum of angles of any given parallelogram, be it interior angles, be it exterior angles, the sum will always remain 360 degrees. Okay, so moving on to the next essential element, that is the diagonals. Let's explore. To begin with, what exactly is a diagonal? Let us take example of parallelogram KLMN. Diagonals are the line segments and they connect the opposite or the non-adjacent vertices. Can you identify the vertex opposite to K? It is M. So the diagonal will be KM and the other diagonal will be LN. But to understand the concept of diagonals of a parallelogram, observe this demonstration. The diagonals may or may not be equal, but when they intersect, they cut each other. For example, you can see the two diagonals, the green and the blue one. Consider one of them like a pair of scissors. You will see the pair of scissors is cutting across, let's say, the blue diagonal like a ribbon into two equal parts or two equal halves, and this process in geometry is called bisection. So we can say that the diagonals of a parallelogram bisect each other. Let us understand the concept of bisecting in detail. Observe the parallelogram KLMN. Now, see how KM is getting divided into two parts at the point O. You can see OK and OM. These are the two equal parts of the diagonal KM. So you start moving from one vertex towards the other. So OK is equal to OM. Let's say if KM is equal to 6 centimeters, then the value of OK and OM will be equal to 3 centimeters. Perfect. You can see that this is how, if you look at the figure, this is how they are going to give it to you, and they will ask you to find the missing value. So you have to ensure that you start moving from K towards M. Okay, going on to the next diagonal, LN. Let's say the other diagonal, it is getting divided at O in two parts, ON and OL. Let's say LN is equal to 8 centimeters. Then the value of OL and ON will be equal to 4 centimeter each. Let's put this knowledge to practice and find the missing values. Find the value of X and Y in the given parallelogram. Pause the video and move from one vertex. Let's take this diagonal SU. So start moving from S towards U. That means 20 is equal to Y plus 7, and the reason for it is there on the screen for you. Pause the video and attempt the question. Y plus 7 is equal to 20. So 7 will get transposed and you will have Y is equal to 13. put the units as they are given. Okay, moving on to the other diagonal. Start from N, move towards R, or from R towards N, making sure that you equate 16 to x plus y. But what is the value of y? It is 13. So we know x is equal to 3. So we found both the missing values. One more example for your practice. Find the value of g and f. You have to ensure that you make your equations correctly. The property, we know we have identified the given element diagonal, and there is only one property, that they bisect each other. So we have 3g is equal to n, giving us g equals to 3. Similarly, 3f plus 5 will be equal to 4f, giving the value of f as 5. Hence, we found g and f. So this brings us to the end of the module, and let us make our conclusion. Let us add the information we have